Yeah, hello, sir. Okay, sir, I
Uh,
will start from my side, okay?
okay, fine.
Okay, sure. So, good morning, Dr. Alwin, and good morning to the participants who are watching this live session. So, ladies and gentlemen, and esteemed guests, and dear friends, welcome to this exciting session entitled Recent Trends in Computer Vision Approaches for Healthcare Applications. We are at a fascinating point in time where the fields of technology and healthcare are converging like never before. So, the rise of computer vision, once thought to be purely for the machines to see and interpret images, is now playing a transformative role in healthcare. And from diagnosing diseases to improving surgical precisions, this field is revolutionizing the way we approach the medicine. And today we are here to dive deep into these innovations and discuss the game changing impact they bring to patient care. So the healthcare industry, as we know, is one of the most dynamic sectors, ever evolving with new challenges and opportunities. So computer vision has the potential to streamline many processes, like identifying anomalies in medical images faster than any human eye, good or even assisting in robotic surgeries. As we gather here, let's open our minds to the possibilities this technology presents. Whether you are a tech enthusiast, a healthcare professional, or simply someone intrigued by the fusion of AI and healthcare, there is something here for everyone. So, by the end of the session, we hope you will walk away not only with a better understanding of recent trends in computer vision, but also with inspiration to think about how these approaches can shape the future of healthcare. So, let's explore and discuss, and most importantly, let's learn how we can leverage these tools to improve the quality of life for millions. So, thank you for joining us today. So before we start Dr. Alwin's session, I would like to give us some short introduction about him. So, ladies and gentlemen, and esteemed colleagues and dear friends, it's my absolute pleasure to introduce today's distinguished guest speaker, Dr. Alwin. So, Dr. Alwin's academic journey is nothing short of impressive. He holds a BSc degree in computer maintenance and electronics from Union Christian College, Alwa, and MSc in electronics from MES College, Maramballi, both affiliated with Mahatma Gandhi University in India. His pursuit of knowledge then led him to Christ University in Bangalore, where he earned his M.Tech degree in communication systems, but his academic achievements did not stop there. He went on to complete his PhD in electronics and electrical engineering from the prestigious Kyungbuk National University in South Korea. So, Dr. Alwin's contributions to the field of technology are equally remarkable. And following his PhD, he joined the Center for ICT and Automobile Convergence at Kyungbuk National University as a researcher, where he played a key role in developing cutting edge and localization and mapping systems for autonomous vehicles. He then moved on to a research fellowship at the University of Michigan and Dearborn, and contributing significantly to projects in electrical and computer engineering. And since January 2023, he has been shaping young minds as an assistant professor at the Indian Institute of Science Education and Research in Thiruvananthapuram and focusing on data science. And beyond academia, Dr. Alvin is a leading voice in fields such as localization and human activity recognition, facial emotion recognition, and human behavior prediction. He has reviewed numerous high impact international journals and contributed as a technical program committee member and session chair for the several international conferences. So we are incredibly fortunate to have him here with us today, and I'm sure we will all live inspired by his insights. So please join me in welcoming Dr. Alvin. So before we begin today's session, I would like to take a moment to introduce you to our company, Temstech Solutions, a Canadian service venture. We are deeply committed to developing innovative engineering management and scientific tech solutions that are tailored to support your ecosystem with a forward-thinking approach. So, what sets us apart is our dedication to affordably without compromising on quality. Our skilled and professional team is always ready to deliver exceptional business plans that cater to your unique needs. So at Temsix Solutions, we offer a wide range of services from digital marketing, web designing, and server management to on-field marketing, Android and iOS app development, telecommunications, AI tools, SEO, and web analytics. So we also specialize in business operations and process automations across the multiple sectors, including industrial research, aerospace and defense, mechanical, automobile, electronics, electrics and energy, architecture and civil engineering, medical applications, and many more. So, no matter the industry, our solutions are designed to enhance efficiency and innovation and growth. In addition to our tech driven services, we are incredibly passionate about education through our initiative, Mastering Up. This is a platform. It's dedicated to unlocking the potential of young learners, providing them with the skills they need for the brighter future. So we warmly invite you to join us in this mission, and whether through guest lectures or sharing your expertise, you can help inspire and educate the next generation. It's a platform where knowledge sharing leads to personal growth and fostering a community of enthusiastic learners ready to take on tomorrow's challenges. So, okay, at the end, I would like to introduce to the motto of Dr. Alwin: innovate, inspire, and impact, pushing boundaries and technology for a smarter and connected future. So I would like to hand over the session to Dr. Alvin, and also thanks a lot for joining us today. And over to you, sir. Hello, sir. Okay, sir, you can start now.
Hi.
Yeah.
So my audio is visible?
Yeah, yes.
Yeah. Okay. So you can share the screen.
Yeah.
Oops. Good morning, everyone. So today I would like to talk about recent trends of computer vision approaches for healthcare application. And my name is Alwin Poulose. I'm assistant professor, School of Data Science, ISER Trivandrum. During the talk, first I would like to give an introduction about the computer vision and the overall healthcare applications. Then followed by I would like to introduce about human intention prediction system. Mainly the human intention prediction system is a combination of actions, expressions, and location information. So we will go through some basics, techniques, ideas, algorithms related to human intention prediction system. Then I would like to extend the presentation talking about human activity recognition detail, some of the approaches, some of the algorithms we proposed, and our some achievement contribution in human activity recognition. Then followed by localization. So in the case of localization, the key idea we work on the indoor localization, identify the human position in indoor scenarios. Then emotion on the human emotions, considered mainly considered as happy, sad, anxious, some set of emotions. Then I conclude my presentation. Then way forward by the future works what we intend to do in systems. So first, when it comes to the introduction side, so first we talk about AI. So the ability of an AI device to predict human intention from actions, expressions, and location. So that's what our key idea from a set of actions, human actions, then expressions, then location. Our main key idea to interpret or predict the future intention or the behavior of a human. So that is our mainly the objective of research. To achieve this goal, first we consider a robust human activity, location, and emotion recognition in indoor and outdoor scenario. But most of the our studies we focus on indoor scenarios. Then, using pervasive, non-instructive, and affordable technologies, we would like to introduce very economical and cheap, low-cost sensors to the system, and the practical implementation of the human intention prediction system with the reasonable resources. Also, utilize the existing infrastructure in the indoor scenarios. Then, similar, the main major application of our human intention prediction, the most important application is healthcare application. Mainly includes like smart home security, driver monitoring systems, then military purpose. Then so many applications also we will consider. So the main goal is like first we consider a set of data sets from a wearable devices or also some set of sensors, then continuously learn the user's behavior and predict their intention from series of activities, expressions and actions and similar. Based on this campaign form, we identify the behavior or intention inside a known environment. So the system already knew the indoor environment or the infrastructure. Based on that, we our aim to develop a human intention prediction system. So first, we start with our planning. Then the first system we consider is human activity recognition system, mainly focus on different types of human activities. Then localization, identify the user position in indoor scenarios. Then emotions. Then fusion system, the subsystems like activity recognition, localization, and emotions together combine a fusion system. Neural model, then implement the prediction system. So this is the main path we followed to achieve our research goal. So here you can see the overall system overview of our human intention prediction system. In the left side, you can see a set of sensors. So in our research, we mainly depends on the Wi-Fi RSSI signals, similar smartphone sensors, IMU sensors, which includes accelerometer, gyroscope, then magnetometer, then similar webcam. So in this research, mainly we focus on our smartphone camera. Similar, some add-on sensors like wearable sensors like our smartwatch is also a good device to accommodate with our industrial prediction system. Then we have a set of sensor information. We do some pre-processing, some signal enhancement techniques, then signal filtering. So if the data is in the image form, image enhancement, image pre-processing, then augmentation techniques. So some set of techniques we pre-processing techniques we implement in the sensor data. Then followed by we have the indoor localization system, mainly identify the user position or to track the user movement. Then human activity recognition. So we had a set of project goal, mainly the system focus on sitting, standing, walking. Then some the exercise activities also we consider jumping, running, sit up, dancing, and lying. So these are some of the activities we consider in our system. Then also facial emotion recognition system. This mainly the work with the facial images. So we have human activity recognition data set. That's also mainly we focus on the images, the camera based system. Then in the case of facial emotion recognition, we consider surprise, sad, neutral, happy, fear, disgust, and angry. So by combining all these subdivision systems together, our main intention is to predict the human intention. So for that, we introduce different types of deep learning architectures, customized architecture, mainly the various convolutional neural network architecture like CNN architectures. Then finally, we predict the human behavior from the set of sensor data. So first we talk about human activity recognition. So mainly human activity recognition is a system mainly identify the human activities or actions. So we have a recognition system. Then prior to that, we have a set of devices which measures some sensor reading continuously. So that reading mainly the sensors most popular is IMU sensor. They record the accelerometer, gyroscope, and magnetometer reading. So based on that, our system identifies some set of activities. So we can consider what are the approaches existing for human activity recognition. The very popular one is vision-based architecture or vision-based approach. Mainly, a camera is mounted in the environment and track the user movement. But the most difficult challenge when we introduce vision-based system is the privacy and also high cost and complexity of the system. So then there another set of approach we can consider is like device-free passive sensing, mainly radio frequency-based technology. So we use the RFID sensors and techniques to locate the user and in mainly in the indoor scenarios and identify the human activities. But the major challenge in radio frequency based system is the environmental interference. So some other set of signal interfere our systems and that will reduce our system performance. So when next is wearable sensor based system. So it's also very popular. The main reason is like we can achieve our human activity recognition system using smartphone or smart watches. So the another key advantage is like location independence, also low installation cost. So these are some of the key factors when we consider as a wearable sensor based system. Then what are the basic activities involved in the human activity recognition? So basic activities we can consider walking upstairs, walking downstairs, falling, jogging, and in the stationary, standing, sitting, lying. So these are very basic activities normally most of the human activity recognition system consider. When it comes to the compound activities, depends on the our scenario or the environment or the application. We consider some set of activities. For example, doing laundry, making coffee, studying, bathing, cooking, watching TV, using phone, using computers, dancing, riding a bike, then exercise, having lunch, reading a book. So these are the some of the set of activities we can also consider for the user activities like compound activities. So here you can see our a human activity recognition system based on the IMU and stress sensor. As part of our project goal, we use the external IMU sensor device. So you can see in the figure, the user was holding three IMU sensor in different position. One it was in the wrist side and foot mounted, then in the wrist side. So similar, we use the stress sensor in the knee part. So by adding all these sensors, our key idea is to track the user motion using the sensor reading. So from that, first we introduce some type of feature extraction techniques. Mainly, the features are extracted in the time domain or in the frequency domain. So in the time domain, mainly we focus on the variance, mean, minimum, maximum, or range of the values. Or in the, if it is the signal, if we consider in the frequency domain, we consider the skewness, amplitude, kudos, and energy. So then followed by the machine learning techniques or the deep learning techniques. Most of the our works we focus on the deep learning techniques, CNN models or deep neural network or RNN or LSTM models. Then finally, our system classify the user activities like sitting, standing, lying, etc. Here also another system you can see based on the smartphone camera. So our previous system we used IMU sensor and stress sensor. So we were thinking about using vision based approach how the system we can implement. So we have a smartphone camera we kept in the one location. Based on that, the camera should cover the entire experiment area. Then we do the user activities and we collect the human activity recognition data set. Then the next test, what we did is that we identify the human object and we remove the unnecessary object from the images. So for that purpose, we use the mass RCNN algorithm, very popular object detection algorithm. So we use the pre-trained mass RCNN algorithm for the human body detection. Then we did the cropping and resizing, also some data cleaning and removal of irrelevant data. So in our main interest is only locating on the human bodies and remove the unnecessary contents from the images. For example, you can see in the block diagram like data cleaning and removal of irrelevant data session. You can see some chair parts or some table or sofa. So we remove these unnecessary things from the our data set. Then the next is data segregation. So mainly data segregation, mainly we have the system with aggregate the all set of images based on the sitting, standing, walking, jumping, lying. Then followed by we use the deep learning architectures to extract the features and model building, training. Then finally validate the system with the classification performance. So here you can see our some human activity recognition results. So the right side we can see the smartphone cameras and IMU sensors and stress sensor we used in our experiment setup. Then here you can see our results. So our human activity recognition approach just used only IMU sensor. The system the performing 90.71 percentage of accuracy. Then stress sensor we achieved 93.80 percentage. Then human activity recognition without hit machine. So this hit machine is our proposed approach. Mainly the block diagram previously I showed. That is the human image tracing machine. So that mainly do some process like you can see in the right side. The conventional approaches use the sensor data pre-processing and a convolutional neural network. But when we are introducing the human image tracing machine, you can see the human body detection and then adding the automatically crop the image, resize the image, do the data cleaning process and do the data aggregation, then followed by the deep learning models. We use the perception ResNet and efficient net architecture to do the activity recognition. So here you can see our last the proposed hit machine. So that is 96.28 percentage of accuracy as compared to other conventional human activity recognition system. Then here you can see some of our implementation. So initially we started with the human activity recognition using IMU sensor in my laboratory. So here you can see in the right side the trajectory tracking. Also in there is a window they are tracking the location information plus the activity information, which type of activities the user is involved. Similar, the next video the user is walking, then again standing, then again sitting, then again do the experiment basic activities again and again using stress sensor. You can see the sensor is placed in the knee side and do the activities. Then here the next video you can see a little bit advanced version with the all combined form of IMU sensor and stress sensor. So here we consider some compound activities, then sit up, lying, and some of the running experiment, similar standing, then do the some type of physical exercise, jumping, then some sit up, some similar, some push up. So this type of some compound activities or some complex activities also we consider as combined form of IMU sensor and stress sensor. Then finally we develop an advanced version just using we removed all type of sensors from our from the user. Then we use the smartphone camera and keep the smartphone camera in your pocket. Then I track the user positions and also identify the user activities. So here in an office environment, what exactly the user is doing, making coffee or drinking tea, then similar office working, working in the office environment. So some of the set of scenario we created and we were tracking the user motions. So next, you can see some of the major application for the human activity recognition. A very popular application you can see in the healthcare, then the abnormal activity detection, smart environment, indoor navigation. So I will discuss more detail about how the navigation is also connected with our human activity recognition system. Then security and surveillance and research and UAVs. So the further some more application you can consider ambient assistant living, human computer interaction, robotics, smart living, healthy living, then the sports also. Human the activity tracking is very popular. So next is our subsystem is the localization. So here also we use the IMU sensor based localization system. Here also we have set of sensor reading or the Wi-Fi signals or the camera-based localization system. And the main purpose is to track the user movement. So by combining this user movement and the activity, we can identify or we can predict some of the behavior or some of the intention what the user going to do in the future. So first system we developed is the IMU sensor based localization system. So we have a set of sensors. So we used a mobile application called Sensor Stream IMU plus GPS Android app. So we installed this mobile application in our mobile phone, and this application can access the accelerometer, magnetometer, and gyroscope sensor reading. So from these sensors, we do some pre-processing techniques and everything. Then from the accelerometer, first we introduce the altitude determination, and also from the gyroscope and using the help of the Kalman filter algorithm, we identify the pitch and roll. Then from the pitch, we identify the step detection, step length estimation, then position. So to get the position together with the pitch information or together with the step information, we use the heading information or the direction of the user. So to estimate the heading, what we use the magnetometer, then gyroscope together. Then we combine with the data together with the help of Kalman filter, like mainly the sensor fusion we implemented with the help of Kalman filter. Then we estimate the heading information. Then together with the heading and the step length information, we identify the user positions. So here you can see right side, you can see how the steps detected, step detection, then step length estimation. Similar sensor fusion using gyroscope and magnetometer, we estimate the heading. So here you can see the heading information result. So in the experiment scenario, we considered three experiment scenario. The user was moving in around a rectangular shape, then also a straight line and a circular path. So here in the left side, the localization result, you can see the rectangular path, the circular path, and the straight line motion, how our proposed algorithm is working or identifying or the tracking the human motions. And then we compare the system with the conventional approaches. So here is the sensor fusion algorithm we developed for the estimation of pitch and roll estimation. So here mainly we collect the accelerometer and gyroscope data, then convert the gyroscope data into quotidian values. So we have the state variable defined as a Q0, Q1, Q2, Q3 as a quotidian. Then we take the transpose so that we define the state variable. So here in the right side, you can see how we define the quotidian values Q0, Q1, Q2, Q3. So here, then followed by we define the system model matrix A. So A is defined in the following the equations. Then define the filter variable, then initialize the state variable, then the prediction part, then the correction part, then return to the estimated value of pitch and roll. Similar, the sensor fusion algorithm for heading estimation. So here, the main sensors are collect the magnetometer and gyroscope data, then estimate the magnetometer heading using the equation. So the definitions, we define the x, y, z axis of magnetometer values. Then also we estimate the gyroscope heading from the quotidian values. Then we define the state transition function, then observation function, then followed by the filter variables. So filter variable we defined in the eta, psi, and a and b. They define these values. Then the prediction, we then followed by the correction, then return the heading estimation values. Then here is the our fused system. So here what we did is that we previous system we were using only smartphone IMU sensor, mainly include accelerometer, magnetometer, and gyroscope. But what we did is that we also considered the Wi-Fi RSSI signals to our system. So here you can see a mobile application. Again, we installed Wi-Fi fingerprint Android app. This application can give the Wi-Fi RSSI signal strength. So based on some trilateral algorithm and fingerprint algorithm, we combine these two algorithms performance results together and estimate the localization or estimate the user position by combining our results from the Wi-Fi system and the IMU sensor based system or the smartphone based system together to estimate the user position. So here you can see how we collected the data. So here we place the same, we consider the rectangular motion of the user. Then we place the Wi-Fi access points or coordinates of the experiment. Then we collect the RSSI data together with the sensor data. Then we propose the fusion techniques to combine the results together to improve the performance of the localization system. So here also you can see how we define the Wi-Fi fusion algorithm for RSSI-based localization system. We estimate the position values from trilateral algorithm. We estimate the position values from fingerprint algorithm. Then we define the state transition function, observation function, then define the filter variable, then followed by the prediction, then do the corrections, then estimate the X and Y positions. So next, we also added the camera-based system to our IMU sensor-based system. So the top part of the system, our previously proposed approach for localization. Then what we did is that we introduced the smartphone camera and the very popular ORB SLAM algorithm we introduced. So mainly that algorithm consists of place recognition, tracking, map, loop closing, and local mapping. So based on then also we added a QR codes in our experiment area. Then UCOSLAM algorithm we introduced. So by adding this together with our IMU sensor-based techniques, we estimate the user positions. So here you can see the contribution. So first we introduced with the smartphone IMU sensor-based system. Our proposed pitch-based step detector achieved around 3.14 percentage of accuracy. Then also heading error, we achieved around 4.72 degree, and our implemented position estimator achieved 2.67 meter of localization accuracy. So next, what we did is that we considered the Wi-Fi RSSI signal. Then we combined with the IME plus Wi-Fi RSSI signal. We achieved 1.17 meter of localization accuracy. Our Wi-Fi IME sensor data with the camera-based system. Mainly we use ORB SLAM and UCOSLAM based techniques with the IMU sensor-based approach. Then finally we achieved 19 centimeter of accuracy. So this achievement centimeter level position accuracy reduce the heading error from the camera-based system. So also provide continuous localization system. So here one more techniques we introduced for Wi-Fi RSSI heat map based technique. So our previous system, what we did is that we used the raw RSSI readings for the localization. But what we did is that we created a RSSI heat maps rather than the raw signal. So we use this heat maps signals as an input for our a hybrid deep learning model we proposed. Mainly that deep learning model we have CNN architecture, then followed by the LSTM architecture. So we have set of training data and test data, and we consider for access point in our experiment scenario. So you can see in the figure how we did the experiments. So we considered 3 rooms, and we did the experiment from the starting position to the end position, and equal distance we collected the training location data, then testing data, then trained with our hybrid deep learning model, and finally estimate the user positions. So here you can see our system. So initially we started with a very basic system without any floor map. So here you can see the IMU sensor data, then IMU sensor data, then followed by like next what we did is that this is very simple system. This sensor was we kept in the user pocket and track the user trajectory. Then what we did is that we made little bit advancement. So mainly we add the floor map, so where exactly the tables and the experiment environment what exactly located. So based on that you can see how the user trajectory is locating using IMU sensor. Also together we monitor the activity of the user. Then our Wi-Fi based system. So here in the 4 corners we kept the Wi-Fi access point. Then using the RSSI data we track the user position. So here you can see the user position is tracking. Then at last our camera based system, you can see here UCOSLAM based approach we did in the real time. So here you can see we kept the camera, the QR codes in the experiment area. Then we track the pose of the camera. Mainly the user was holding the camera and moving in the experiment scenario. Then finally we were tracking the user's trajectory. So these are the some of the system we implemented in the localization research. So here also a little bit advanced version by combining multi-user. So together, previously our research we used only single user, but we combined with the multi users. Then we were tracking, but this system was not very accurate due to the step size. Sorry. So due to the step size of the user, you can see the trajectory is like different. So this mainly the height of the user similar. The step size of the user depends on the system. So multi-user activity recognition system, activity recognition indoor localization system, we had lot of challenges. So here you can see the application of localization system, mainly manufacturing, then military, logistic, public transport, agriculture, then research and UAVs. So next, after localization, our next subdivision we consider as emotion recognition. So emotion recognition mainly divide in facial expression recognition, or facial emotion recognition, or speech emotion recognition, then physiological signal. So mainly we used ECG, EMG, or EEG signals for identify the emotions. Then multimodal information. So in multimodal, we combine the systems together to identify the user emotions. So first we talk with our facial emotion recognition system. So we collected the facial images using a camera. Then also we added with the smartwatch and voice signal for further multimodal system. So first we focus on the image based system, only camera based system. Then we do the some type of image enhancement techniques. We also introduce one system with the foreground extraction based techniques. Also we identify the facial landmarks, also facial heat maps, then EG based system or voice signal based system. Then we create a feature vector extraction. So here mainly extract the features from each component, and we use the deep neural network architectures to classify the user emotion. So here the right side you can see how we collected the data. We kept the camera in front of the user, and the user was trying to imitate the emotions. So we played some YouTube videos or the videos related to each emotions. We played in front of the user, and the user was watching the video and simulating the emotions. Then we tested the system within the real time scenarios. So here the system was achieved around 50 percentage or 60 percentage accuracy in the real time scenarios. So here you can see some of the data set we used for our emotion recognition techniques. So here you can see the raw image signals. So first we implemented the system with the raw signal. So that will cause some challenges like background, the curtain or window, the some unnecessary noise in the images will reduce the system performance. So we implemented a foreground extraction techniques. So in this case, we removed the background and made into only the face of the user, like enhanced using 400 extraction, and remove unnecessary noise and background images from the raw input. Then facial landmark, the another techniques, like we estimate the facial landmark we from the raw image, and we use the landmark information for the emotions. Then also only heat map based techniques. So in heat map based techniques, what we did is like we just extract only the key points from the raw images, and use these techniques for the emotion classification. Then similar ECG signal and voice signals also we collected at the same time to keep on adding or implementing the multimodal emotion recognition system. So here you can see facial emotion recognition different system only using foreground extraction based techniques, mainly removing background images and enhance the user faces to get the exact features for the model deep learning models. Then similar you can see the landmark based system. So here from the raw data we extract the landmark, then using that landmark as the input of our deep learning architectures and identify the user emotions. Then some work on kernel sharpening techniques. So we introduce the kernel after foreground extraction. We introduce the kernel filtering to the images that will enhance the raw input. Then enhance the raw images and will give more information to the deep learning architecture and do the emotion classification. Similar, one more approach, we introduce the 3D face reconstruction from the 2D images. So we have the 2D images and we convert the 2D images to 3D image. Then you can see the 3D data from the 2D data. Then we give these 3D images as an input of our deep learning model and do the emotion recognition. So here is some of the summary of our approaches. Most of the system outperform more than 96 percentage accuracy. So each system, they have their unique advantage and challenges also. So here you can see foreground extraction based approach 98.67 percentage, facial landmark based approach 97.51, then kernel sharpening 96.17 percentage, then 3D face reconstructed based approach 98.8 percentage of accuracy. Then speech emotional recognition. So as followed by the facial images, we also work with the speech signal. So here you can see the input of the system will be speech signal. So mainly it's generally you can call it as a sentimental analysis. Then from the features, we do some pre-processing, mainly padding or truncation or silence region removal, then filtering, framing and windowing, then short time Fourier transform. So from this, we extract the features, mainly MFCC or MEL spectrogram or chromogram, then introduce the deep learning model and identify the user emotions. So here you can see some of the MEL spectrogram of each features, like for the male, female, for each emotions you can see calm, fearful, sad, male, similar for male also, surprise, and then angry, then male happy. So here you can see the MEL spectrogram. The MEL spectrogram gives a different pattern for each emotion, also for each the gender. So based on these key characteristics, we can estimate the user emotions. So here you can see our deep learning proposed architecture. We proposed a deep learning architecture mainly. The model we call is like RES by LSTM, then RES by LSTM with the attention model. With the you can see the right side the proposed architecture. Then here we tested with the different publicly available speech emotion recognition dataset, very popular EMODB or URDU or Roughness or SAVE. So this system we tested with our proposed deep learning architecture, and we analyzed with the accuracy, precision, recall, and F1 score. Then similar, we introduce some transform encoder with a multi-head attention-based deep learning model for speech emotion recognition. Here, what exactly we did is like we extracted chroma, contrast, MFC, MEL spectrum, zero crossing, RMS power, and pitch features from the raw input speech signal. Then we propose the CB2MA model. So this is our proposed architecture with the transformer models, transformer encoder with the multi-head attention model, and we tested with the other deep learning models to show our proposed architecture performance. Similar, compared to previous system, we also did some work on the EEG-based emotion recognition. So here you can see we use the publicly available datasets called deep dataset. So from that, we have three emotion categories. So when we use EEG signal, the emotion categories are changed to positive, negative, or neutral. So we have the label data with the positive, negative, neutral data. Then what we did is that we collected the data, publicly available data. Then it's mainly called EEG brainwave dataset. Then from that, we implemented with most of the machine learning models with some parameter tuning, hyperparameter tuning, and also we tested with the different aspects of the machine learning model to improve the emotion recognition system performance. So here you can see our performance of the system with all machine learning models. We tested with most of the machine learning model for EEG-based emotion recognition system, and most of the system outperform more than 96% of accuracy. So here you can see some of the application of emotion recognition, very popular face identification, driver monitoring system, then 3D face reconstruction, then intelligent robot. So finally, conclusion, you can see we worked with the human activity recognition system, mainly sensor-based system approach. We reached 90.71 percentage of accuracy. Then stretch sensor-based system 93.8 percentage. Then camera-based system 96.28 percentage of accuracy. Similar localization system. So here you can see IME sensor-based system achieved 2.67 meter of localization accuracy. Our Wi-Fi based localization approach achieved 1.35 meter. Similar hybrid localization system we combine with IME sensor with the Wi-Fi. We have 1.17 meter of localization error. Then IMA plus camera 19 centimeter of localization error we achieved. Then in the case of facial emotion recognition, the emotion recognition, facial emotion recognition maximum we have 98.8 percentage accuracy. Then speech emotion we have 98.44 percentage of accuracy. Then the physiological signal when we used we have 98.59 percentage of accuracy for emotion recognition. So these are the our publications. Most of the all research, it's most of the things are available online. So any one of you would like to read or to know more details about the work, you can go through this publication and you can see the most of the systems in detail, most of the algorithms and everything. So way forward in the future, we would like to add human pose estimation to the our system, similar eye tracking. So eye movement also we would like to add on with our entire system. Then improve the performance of the human behavior system. So until now we discuss about the individual system and combining or fusion system. Still the work is going on, but we have a lot of challenges, so that we are trying to address these challenges to enhance the intention prediction system. So here the very small description about human pose estimation in the future we plan to do. So here you can see human body modeling, mainly kinematic or planar or volumetric. In the right side you can see the difference. So also 2D human pose estimation, then 2D multi-person pose estimation, 3D human pose estimation, similar 2D to 3D based human pose estimation. So mainly the devices IMU, RFID devices or depth sensor. Then also Wi-Fi based system also you can use for human activity recognition. Then some of the dataset MPII or human EVA or post track or human 3.6 million. Then ground truth evaluation, normally most of the cases we use the OptiTrack. Then some of the libraries open post detection, dense post, alpha post and HRNet. Then eye tracking, mainly the methods involves EOG or scalar search coils or infrared or video-based approach. So mainly we focus on the video-based approach. Then type eye trackers or screen-based or head-mounted eye trackers or mobile. So some of the publicly available data sets. Then the software we can use for the tracking purpose, eye tracker or eye tab or open eyes. So, and finally, I would like to share the PhD program at our school. So, our School of Data Science, we provide PhD program in data science. So, mainly, if you, any one of you would like to join our research team, always welcome. Send an email to my official email ID and bolospalati at isrtvm.ac.in. And here you can see most of our research domain. Mainly we work with the deep learning architecture, customizing the deep learning architecture, then computer vision topic, intelligent system, then image processing or signal processing, then emotion recognition system, most of the classification systems you can see. So if anyone would like to do their higher studies or PhD, then always welcome. Thank you for your attention.
Yeah, thank you, sir. Thank you so much for the wonderful presentation. So I have some questions here. So shall I ask a question, sir?
Uh, Sorry, yeah, you can ask the questions.
Yeah, sure. I will ask the questions. Okay, so in my first question, how will advancements in computer vision improve yearly detection and diagnosis of diseases in the next decade?
So, computer vision for, sorry, I didn't clear that question. Can you repeat?
Yeah, sure. How will advancements in computer vision improve yearly detection and diagnosis of diseases in the next decade?
So in that case, currently our system, our medical AI research team, they are working with some clinical data and everything. So the current research, I can say, like mainly my colleagues working in this topic, they are synthesizing the data. So some of the synthesization normally we do using transformer-based architectures. So the key idea is like early detection of the diseases. Also, my friends, they are working with the cancer. Then also some other set of colleagues, they're working with the MRI based systems. So using that, the early detection at some level, we can, based on this deep learning architecture, some level we can identify the early detection. And in the future, what we are doing is that, like, we are bringing the diversity of the type of data sets, and by generating using like computers, like using the deep learning architects, we generate or synthesize the data and bring the diversity to the data to give a advanced level of determine the diseases in early stages.
Okay, thank you, sir. So, what role can computer vision play in personalizing healthcare treatments based on real-time patient data?
So mainly current systems, you can see some of the hospitals also do the real-time monitoring. So the patient monitoring, normally most of the hospital they keep a camera, or some cases they keep some sensors in the patients, and the doctors or the team always monitor the patient's changes, or some so always give the warning. Similar, the another major application is the elder people at our home. So if they are at our home, then keep a cameras in our homes and always track their motions. If any abnormal fall happened, or this type of things happens, or some abnormal activity happen in our system, then the system give the warning to the user side, like in using our mobile phone or some our computer or laptop. Using the server system, we can easily identify some type of abnormal activity happened inside a home, if we are tracking our old people at our home. Or similar same scenario in the hospital case also, some type of abnormal activity or issues happen in the patients, we can easily monitor that one.
Okay, great. So, sir, in what ways can computer vision technology enhance the accuracy and efficiency of robotic surgeries in healthcare?
So currently the robotic the research is like currently very hot topic, I can say. So the robotic movement and everything. So currently I'm in some level, some intermediate level of surgeries and everything is like happening. But not in very advanced level. It's like a very hot topic. Currently the research is going on. So mainly this idea happens in the human computer interaction. So some places the robot can do efficiently as compared to human, but always there will be a challenges if what will happen to the system failure. So that's also a very significant matter we have to consider, or what will happen for the machine error. So these are the main challenges we can think about in robotic surgery area.
Okay, thank you, sir. So, my last question. What are the potential challenges of integrating computer vision with wearable medical devices for continuous health monitoring?
So the main challenges we can say, like the first challenge is the cost of the device. So
Hmm.
that always we have to compromise. It's very expensive devices. So that's the first challenge. Second one is like when computer vision, when it comes, there should be a privacy issue. So we cannot escape from that. So whenever if we keep a camera in the system or computer vision, so then privacy of the user is the main challenge. There are always some fight against with some people that our privacy is the first concern. We cannot reveal our privacy. So some ethical consideration should be there. So that is the when we work with the medical data, the major concern is the ethical issues. So the patient data should be confidential. If we cannot reveal the data or information, patient information to the outside. So that's a main issue. Then yeah. So then when it comes to the integration side, there are so many challenges in the system sides. It's not a very straightforward. But the primary challenges, I can say, the ethical issues. Also, when we are introducing this deep learning or artificial intelligence, there is also the huge concern about the ethical concerns. So that is the main thing I can say.
Okay, so thanks, sir. Thanks for the useful answers. So that's very useful. I hope the access and that the participant understand about everything. So it's finally so, ladies and gentlemen, it has been absolute privilege to have Dr. Alwin with us today, sharing his invaluable insights on the recent trend in computer vision approaches for healthcare applications. So on behalf of everyone present, I would like to extend our deepest gratitude to Dr. Alvin for his enlightening talk. his expertise and contributions to the field of localization and human behavior prediction and healthcare technology have truly inspired us all. So, Dr. Alvin, thank you for taking the time to guide us through the future possibilities of computer vision in healthcare, and your passion and knowledge have left us with a wealth of ideas and opened our minds to the exciting potential that lies ahead in this field. So, we appreciate your willingness to share your research and experience with us today. So, once again, a heartfelt thank you, Dr. Alvin, for your time and wisdom and for being with us today. So we look forward to following your future contributions to this ever-evolving domain. So thank you, sir. Thank you so much. And please, sir, just wait a few seconds. Okay, sir, can you able to see the virtual memento?
Ah, yes, yes.
Okay, so on behalf of Mastering Up, we present this visual memento as a tribute to our guest speaker, Dr. Alvin. So your insightful contributions have enriched our knowledge and inspired us profoundly. So this is token of appreciation, symbolizes our gratitude for your expertise and dedication. So thank you for sharing your wisdom with us and shaping our understanding in profound ways. So thank you, sir. Thank you so much.
Thank you for this wonderful opportunity. It was a good experience to share my knowledge to the outsides. Thank you so much.
Thank you, sir. Thank you so much.